Hello. Today's demo is an unusual one, consisting of MQTT, Kafka, and Fields Online. All of them are running on OpenShift. Let me just tell you about the use case. It's an IoT use case. Assuming the IoT devices are sending telemetry readings to MQTT or AMQ, and then MQTT or AMQ is passing that information to Kafka. And we also take the data from Kafka and save it on a file. I've actually created integration using Fields Online instead of using Kafka connectors. I have created a video for that. You can see the video to understand how that is done. This is a summary of that. So I'm using Fields Online MQTT connector, connects to a Fields Online Kafka connector, and then have a Kafka Online connector connect back to the Fields Online FTP connector. So the flow of information is like this. From the IoT devices, they send MQTT messages to AMQ using MQTT protocol. And then the integration between MQTT and Kafka processes the messages to Kafka in a topic. And then there is another integration which takes the messages from the topic and save it onto a file using FTP. That particular demo I've shown in the previous video is working, but it's not that interesting. Now this is a more interesting demo using the same sort of integration. So it consists of a robot which I call Max, and I can control Max using a web application by moving the arrow left, right, top, turn right, turn left, go straight ahead, move backwards, position the camera, turn on and off the laser, etc. I modify that web application so that it will also send an MQTT message to a topic to AMQ. And the integration will pass it on to Kafka, save that in the topic. And then there's another integration from Kafka taking the messages from the topic and move it to a file using FTP. And then I retrieve that file from FTP and wrote a very small Java program which look at the messages and then pay them back using a WebSocket connection back to the robot. You can see that these events are captured in JSON. You can see the ID, time, and command. By using the time, I can find the difference in time and then pay back the commands at the appropriate time. Actually, this is an event sourcing design pattern which is popularized by Martin Fowler in his book Design Patterns for Enterprise Application Architecture. So if you want to find out more about the project, you can go to this particular web page where I actually describe my project here. So let's have a look at the demo. Now, Max is sending you a message in a neutral color green instead of red or blue. Got the message? Now he's happy. This is the web application I talk about. Now you can use it to control the robot. You can also see the pictures that through its camera. Now I'm actually turning on its laser. You cannot see it yet. Now you can see the laser dot. I'm actually using the web interface to actually control its movement. So it's moving forward. Now I'm recording the movements here, like using the controls in that web application. Whenever I click on any of those controls, the commands are actually sent over to AMQ topic using MQTT, and AMQ will pass it on to Kafka topic using that views online integration. And there's another integration going on from Kafka, reading the messages from that particular Kafka topic and send the information to a file using FTP. Again, using views online. Now it's almost finished recording. Now it's coming back to its original position, and that's the end of the recording. Now I'm actually playing it back right now. So what happens is after it finished moving the data from Kafka topic to FTP site in the file, I downloaded that file and wrote a Java application to replay the commands back to the robot. There is actually a WebSocket interface that I can send from my computer to the robot to repeat those commands. So it's actually retracing exactly the same movement or path around the mat. Now it's almost coming back to its original position. And that's the end of the demo. Thank you very much.